Today we are talking about domain, range, and discrete values or discrete functions. So domain is a set of all possible x values, and range is a set of all possible y values. Discrete function or discrete data is our next word that we're going to look more into. Countable data that only includes integers. Do y'all remember what integers are?
I don't remember.
They're positive and negative whole numbers, including 0. So they have to be whole, but they can be positive and negative. Okay, so that'd be like 0, 1, 2, 3. But it could also be -1, -2, -3. So this is an example of integers, positive and negative whole numbers. So discrete does not include any fractions. No fractions, not fractions, unless they can be divided evenly. And also not decimals, fractions or decimals. So something to help us with domain and range is this page right here, doXin rYde. So whenever we talk about domain and range, if you forget which one's which, then I'm going to say doXin or rYde, and I'm going to help you remember that. So let's turn to the next page in our journal. And we are going to cut this out. And then we are going to make these little flaps like this. Yes. So you're going to, everybody look at the screen real quick. You're going to cut it out around and then just cut to that middle point, to the cross or to the origin, if you think about it mathematically. And we are just going to glue this in. And we'll write some things underneath the tabs. Don't put a ton of glue. Dot, dot, not a lot. So under this doXin rYde, these are ways of remembering domain, range, independent, dependent, x and y. So anytime that you're not sure if it's domain or range, I'm going to say doXin rYde. And that's hopefully going to help you remember domain is x, range is y. So under the doXin, the little wiener dog, we are going to write the word domain. So whenever you think of doXin, you're going to think of domain. So the DO in doXin represents domain. So DO here. The IN represents independent variable. So that's the IN. And the last thing is cause. So the X value is going to cause something to happen to the Y value. So the doXin is all about our X values of a relationship. Remember, a relation is just a pair of X and Y values. So then rYde, if doXin, domain, rYde, the R stands for range. The DE, if X in doXin is independent, then the Y in range is dependent. And if the X is our cause, then Y is the effect. doXin is our X values, rYde is our Y values. So doXin, rYde. So the first type of data we're going to look at is called discrete data. A discrete unit is indivisible. Indivisible. Where have you seen the word indivisible or heard it? Yeah, in the pledge. I pledge allegiance. And then it's one state under God, indivisible, liberty and justice for all. Indivisible means cannot be divided. So within the pledge, it's the United States cannot be divided. With data, it means the unit, whatever unit that we are counting, cannot be divided. So there are no fractions or decimals. We are going to count discrete data. Literally count, like I can go around and I can point at each one of you and I can count how many of you there are. A collection of data, or I can't talk. A collection of discrete units will be complete units. Like, I wouldn't say, whenever I count each of you, I wouldn't end with, there are 14 and a half people, because it can't happen, right? We can't have half of a person. So discrete is going to be complete units. There are 14 people in here, and that's what a discrete data is. I can literally count each one of you. So for example, people are discrete type of units, because I wouldn't say a half a person. Even if someone only had half of their body, you wouldn't count them as a half a person, right? You wouldn't say I have 14 and a half people. You would not. That would be rude. How?
If you have permission, you can.
No. You would never say 14 and a half people, because it's still a person. All right. Next thing is calculators. I could count all the calculators in this room. I could count shirts. And we could also count pets. You would say I have 3 pets at home. There would never be, I have 6.5 pets. Like, that doesn't work. You count them. No. The graph of a discrete function will be made up of coordinate pairs that do not connect. So do not connect. Discrete graph will just be a set of points. That's it. They don't connect at all. So if we look at this graph, it says inning and number of runs. So let's talk about baseball. So 1 inning, 1 run. Would you be able to count if they went to second base but didn't make it all the way to make a point? You wouldn't count it. So that's why this is discrete data. You would not connect them, because at 1.5 innings, you couldn't have 1.5 runs. It just doesn't work that way. You only count at the end of the inning or during the inning, but you can't count part of a run. It's like counting the eggs before they hatch, you know. So the important thing here is points are not connected.
What about the dogs that have the weird babies?
They're still considered a dog.
And they have.
No, it's a dog. Can't say I have half a dog and he still runs up to you even if he is on wheels.
See wheels on.
All right, go ahead and glue that in on the next page, and we are going to do our last set of notes. All right, so on this one, we are going to fold it. So we were able to take this off. Whenever you cut this, be really careful that you don't cut anything off of this side. We already did that. But once you fold it like this, open it back up, and you're going to cut where the tab should be. So right above the 3. Between the 3 and the 5. And between the 5 and the 7. So that way you're not cutting anything off. If you have it open while you cut, you can make sure that you're not cutting anything off. Just because the copier didn't do it exactly on that dotted line. There's a little mistake. And so you can close it. It doesn't matter. This will go on the next page once we're done. But let's go ahead and do the notes first. Oh, I'm going to move it around. Nope. Don't glue it just yet. We're going to fill it out first. All right, so discrete data is represented by just numbers, right? It's not connected. It's points on a graph. It's discrete data. It's countable. So the way you represent discrete data is by ordered pairs, a table, a mapping, and a graph. So we are going to find the domain and range for the discrete data. So remember, domain is doXin. Domain is our X value. Range is rYde, which is our Y values.
Why is rYde spelled with a Y?
So that we can have the Y values. Just like this isn't how you really spell doXin, like the dog.
Oh, I thought it was.
No. It's like DASH. It sounds like dash hound, but it's not. It's doXin. I don't know. So let's look at this set of ordered pairs. We have the ordered pairs X and Y. So we have all the X values. So the way we could list out the domain is first by underlining all the X values. And when we list them out, we want them in order from least to greatest. So we want to look at, okay, -6, 0, 2, 4, -1. The smallest number is -6. So I got that one. And then -1, 0, and 2 and 4. Yep. You do need to put a little curly brace around it because it's the set of X values. So the way I do my curly brace is I do an S, and then I do a backwards S. And then you could do a backwards S and then a forwards S. Some people do it like this, which that's fine too, but this is how you would do the curly braces if you want to try to make it look like that. So this is the set of all X values. So then we need the set of all Y values for the range. So let's put 2 lines underneath the Y's. And we'll do the same thing, list them from least to greatest. If there's a repeat, you don't list both or that number twice. You just list it that one time. So we have 7, 2, 3, -6, 2. I'm not going to write 2 twice. I'm just going to write that one time. So let's see, what is the smallest number?
-6.
Yeah, it is -6. So -6. I forgot to check that off. Check those off. And then 2. Yeah. And then you don't have to list it again. 3 and 7. And then put the curly braces around it. And the last thing I want you to do is decide whether it's a function or not. Yes. So none of the x's repeat. The y repeated, but that didn't matter. We still have -1, 4, 2, 0, -6. No repeats. So yes, it's a function. It's okay. All right, let's go to the table of values now. Remember, domain is all our x values. So we are going to just list out our x values. So 1, 2, 3, 4, and then there's another 3 there. Okay. So we're just listing them out, all the x's. And now the range, right, is the y values. 5, 6, 5, 6, 7. Just 5, 6, and 7. Okay, so do any of the x values repeat? Which one? Yeah, 3 repeats. So it is a no, not a function. Okay, the mapping. List out all of the x values from least to greatest. Go ahead and do that. List out your domain and range. Yep. So domain, least to greatest. It looks like they're already in that order, which is great about, what's great about the mappings is that they are in least to greatest order. -1, 0, 1, 2, 3. And then our range, they're in order too. 0, 1, 4, and 9. And then to determine if it's a function, yep, no x's repeat. Remember for mappings, it would have 2 arrows coming from it going over to the right side. And each one of these have their own just single arrow. So yes. Okay, let's go down to number 7. We have a graph here. What makes this hard is that I can't see the origin very well, so that makes it hard. So I'm going to go ahead and just Make your X and Y a little darker and go ahead and label them X and Y. And in order to know what our X and Y values are, we've got to find the coordinates. So let's look at each one of these points, and we've got to write the coordinates. So we can start with this one. Start at the origin. What is it? Yeah. Okay. Go ahead and write it on your graph. And then go to the next one. Let's go to the one right above it. It's also 2 up to 4. Yep. And then go all the way over here and down. 5, -2. And then we'll go to this one. -2, -1. And then this one. So then domain is all of our X's. So it's the first one. So I'm just going to underline all the X's. The first number in each set. And we want to go least to greatest. So what's the smallest X? Yeah. Which it happens to be the furthest left. If you think about the X-axis, it's going left and right. Furthest left is the least. And so let's go a little bit forward. -2. A little bit more forward. 2 first. And then 5. And then our range is all of our Y's. So put a double line underneath all your Y's. Okay, so our least would be our lowest because our y-axis is going up and down. So we go all the way down. Yep, -2. Up. And then, and then 4, yeah. To match there. Okay, and then is it a function? No. What makes it not a function? Yeah, that right there makes it not a function. All right, so I did the odds for y'all, 1, 3, 5, 7. So now you're going to do the evens, the ones on the other side, 2, 4, 6, 8. Once you finish, then you can glue it in your journal.
We have